Can you hear me? Ah, that was way better than last time.
Welcome to Books, Booze, and Brains, a book club for the scientifically curious. Thanks for joining us, and we hope you enjoy the show. Every month, we meet at a local brewery in Indianapolis to discuss a popular science book with an expert in that book's field. Please enjoy the following excerpts from our discussion on Brain on Fire, My Month of Madness by Suzanne Callahan.
Dr. Sullivan talk about himself, which I hear you can do pretty good. So, take it away. Tell us about your research.
All right. Can everybody hear me all right? All right, great. So I guess my interest in this topic emerges from the work I do in my laboratory. I'm a professor over at the IU School of Medicine on the west side of town here. And my laboratory studies infectious disease, primarily this parasite called Toxoplasma gondii, which about 1 out of 4 people in this room have in their head right now. It's an extremely common parasite that we get from our cats and that we get from contaminated food and water. Despite how prevalent it is, it's not a household name because it doesn't cause any overt symptoms, but it doesn't leave your body, ever. You can't get rid of it. And what disturbs us and what interests us about that is that in mice that are infected with this parasite, they exhibit some pretty dramatic behavioral changes. And that kind of opens up the window to what I'm really interested in, how parasites and a multitude of other things affect our brain and how that translates into affecting our behavior. Susanna was really exhibiting a lot of symptoms of what we would characterize as demonic possession. Okay, she was considered to be possessed. And you can imagine many people throughout our history, in times where we didn't know anything about neurology, when they started exhibiting these erratic behavior patterns, speaking in tongues, having movements they can't control, fading in and out of consciousness, if you didn't know anything about modern day medicine and neurology, you may attribute that to the supernatural or being possessed by demons. Now, despite all of our advances, there are still a large contingency of people who believe in demonic possession, okay? So I was interested in that topic and I wanted to see how real it got. So the Catholic Church, according to my Google research, has at least 10 official exorcists in the United States on call that you can alert if you believe someone is demonically possessed. I pictured them sitting around in a firehouse somewhere like Ghostbusters. They get the call, they slide down the pole, and off they go in something like a Pope mobile, ready to rescue the person. And speaking of the Pope, in 2014, not that long ago, he attended something called the International Association of Exorcists. So at one of these conferences, there was a reporter, and he was interviewing one of the leading exorcists there. And I just want to quote this because I find it oddly amusing, and it answers the question of how you can really tell if someone is demonically possessed versus whether they have schizophrenia or a multiple personality disorder or epilepsy. So here's a quote from this Reverend Caesar that he spoke to. He said, "Once you hear a satanic growl, you never forget it. It's like smelling margarita pizza for the first time." It's something you'll never forget. Actual quote, that was said in the interview. So I can't eat pizza anymore without thinking about demons and satanic growls, you know. Usually there's a satanic growl in my stomach before I eat the pizza, but this isn't something indifferent. But it's actually, exorcism is a serious topic. There are people who try to do this themselves or with a group of friends, and it has led to injury and even death in some cases, usually in babies or small children who these people believe are demonically possessed. And it deprives them of a medical treatment that could actually remedy their condition. The question was, patient zero, was there a certain geographical area that was enriched? How did they go about identifying this disease? It's a really good question, a great medical mystery. This disease, we didn't know about it at all until 2005, so it's very new. And a fellow named Joseph Delmu, I believe his name is, in Spain, was the person who originally identified the first patient population, and it was in single digits, very, very low number. But he basically suspected an autoimmune disease because he could rule out everything else, and he knew there had to be a biological basis for what was happening with these individuals. So what he did was he withdrew some cerebral spinal fluid from these patients, which would have antibodies, and he basically screened that against a number of different tissues that he had from a mouse or a rat. So you can section different tissues and organs, spleen, heart, kidney, brain, all on slides, add the spinal fluid to it, and then you can see if those antibodies stick to anything. So when he did these tests, he looked at spleen, they didn't stick to spleen. Look at heart, they didn't stick to heart. He looked at brain, those antibodies stuck to brain, specifically the hippocampus. So then that's when the light bulb went off and said, we're dealing with a neurological autoimmune disease that's causing encephalitis in these patients. And if we can get the immune response dampened, we may be able to save them. So that happened in 2005. I don't believe Susanna was diagnosed until around 2009, and she was only the 217th patient to be diagnosed. And we know today there's well over 1,000 people who have been diagnosed because now we know what to look for. How well known is this in the medical field? I would venture to guess it's better now than it used to be, thanks to Susanna's efforts in making this more widely known. But back in the mid to late 2000s, this clearly was not on the radar of many doctors for understandable reasons. I think the first doctor she went to, or one of the first, Dr. Bailey, I think his name was, pretty much dismissed this as either a stress-related condition or maybe some other standard medical. So you've been told this before? you go to the doctor with some complaint, and it's just, oh, it's just stress. You know, have a good sleep. But obviously, her situation deteriorated to the point where it clearly was not just stress or anxiety related. And fortunately, she had the resources and the people surrounding her to engage in all sorts of different medical tests. And I believe the figure crept up to $1 million worth of medical tests. For those of you who didn't read the book, you know, that's a staggering amount of money. I mean, $1 million is probably what, a PET scan? Medical costs are exuberant across the board, but there must have been an extraordinary number of things done to her to try to figure out what was going on. And all it took was the right person in the know, and that was Dr. Najjar. Yes, he was the one who just happened to be familiar with this fellow in Spain and his work, and he was able to put two and two together. And in a test that cost nothing more than the price of a piece of paper, he was able to diagnose that she had some sort of neurological disease when he asked her to draw the clock. And everyone who's read the book probably remembers the unusual clock that she drew. For those of you who didn't see it, when she tried to draw a clock, she put all the numbers on the right half of the clock. So 1 through 12 were all there, but they were all between the numbers 1 and 6. They were all on the right side. So I think everyone realizes that the right side of your brain sees the left, and the left side of your brain sees the right. So Dr. was able to figure out that there was something wrong with the right side of her brain. It was not seeing the left side of the clock. In her mind, she probably saw a correct clock, but that's clearly not what reality was producing. So one of the things we don't recognize every day about our brain is that it's a reality simulating device. The whole purpose of our brain is to give us a picture of our environment. And it also gives us a picture of ourselves in that environment. So when you have damage done to a certain part of the brain, in her case, the right hemisphere, you have a collateral damage in your reality simulating device. And that's exactly what was going on. That's why she had hallucinations and delirium and confusion, because her brain was simulating a different reality than what we experience. Right. So memory is, again, a really good question. We have no idea what's going on with memory. What I can tell you based on what the limited knowledge I've read, and I've forgotten most of it, it's just ironic, right? But the hippocampus, one of the primary regions of the brain which these antibodies attack, is the center for memory processing. There's two major flavors of memory. There's short-term or working memory, and then there's long-term memory. So the hippocampus is where those short-term memories get converted into long-term. So I'm willing to take a guess that her short-term memory was probably fine, but anything she experienced could not be recalled because it was never processed into long-term memory because of the damage to the hippocampus. Okay, so we've made a lot of progress in the past 10 years based on cases like this. So a brain biopsy might not be necessary in every patient these days. It was back then because we really didn't have a good idea what was going on. She was only the 217th instance where this was diagnosed. And I think in today there's well over 1,000 people who have been diagnosed with this condition. I imagine they would just take some cerebral spinal fluid, which you can get with a spinal tap, and screen a panel of potential autoimmune receptors, such as the NMDA one that was the centerpiece of this book. And you could probably screen for other autoimmune diseases while you're at it. But your point is very well taken about mental illness. We know these days that there has to be a biological basis for it, but there's so many diseases of the mind that we don't have a good handle on yet, schizophrenia being one of the major ones. People have been looking for genes that are associated with schizophrenia for years now, and they've been looking at other factors as well. And we still don't have a really good idea what causes it. I'll also note that the parasite I spoke about in my introduction, this toxoplasma parasite, has been linked to schizophrenia as well. So there may be a combination of environmental factors like parasitic infection, a person's particular genetic makeup, and maybe what else they've been exposed to in the environment, coming together in a perfect storm to create the disease. And that may explain, since it's multifactorial, why it's so hard to pin down and why it's so hard to treat. Yeah, I don't remember if this was mentioned in the book, but some of the research I did suggested that approximately 10% of schizophrenia patients, or patients diagnosed with schizophrenia, actually carry the same antibodies that Susanna had that were attacking her brain. So they were possibly misdiagnosed with schizophrenia and actually had a treatable condition. To the best of my knowledge, this really doesn't appear until the early 20s. Like most mental diseases actually occur, schizophrenia is the same way. We usually tend to see these neurological diseases appearing early in adult life, very rarely in children. But it's probably not a coincidence that the brain pretty much is developing until about the mid-20s. So there's probably something particular about the final developmental stages of the brain that may bring things like this on. Plus at that age, if there are environmental factors, that would be perhaps the amount of time that's required for those to settle in and unfortunately create these symptoms or combine with genetics to do these things. And I think that might also, in this particular case, be associated with many of the cases are linked to a tumor. In the book, they describe these teratomas, and they could be the possible source of where these antibodies get made in the first place to attack this tumor, but then they do collateral damage in the brain. As I said earlier, some of these are associated with teratomas, and most of those don't arise until about that age as well. The question is, what's going on in the brain? Why do we take so long to develop? And that's a great question. We are the only species of animal that comes out of the womb extremely premature. We are totally incapable of surviving without parental care. There's no other animal in the world like that. This is a side effect of us having such a large brain, and it really doesn't come very pre-programmed. That's what mom and dad and the environment are for, to load it with environmental specific information so that child has the best chance of surviving long enough to have his or her own children. So the brain takes an incredibly long time to develop in humans and some other primates as well. We know that the first stage of development happens right at the first few months. There's just an explosion of connectivity in the brain as the infant is learning basic motor skills and how to talk and things like this. And then it kind of chills out for a while, and then we see another explosion with puberty, roughly around 12 or 13, and we're all familiar with that. I'm dealing with it once again, reincarnated with my son. Going through all that, and that lasts for another few years, and then I wouldn't say there's anything comparable to the magnitude of puberty again, but science has unexpectedly shown that the brain is still developing a lot of neural connections in our early 20s, and then it seems to taper off. And then we start to go the other direction, which I'm also experiencing at this age. But there's still a surprising amount of neuroplasticity that is maintained within the brain, so that if we do get an injury or a handicap of some kind, there's another brain area that might be able to compensate for that. So the brain is a wondrous organ. It's the most complex organ, the only one that's ever evolved with the capacity to understand itself. Try to imagine a spleen doing something like that. The spleen doesn't care what life is all about. Only the brain really does. So it really defines who you are. The point I'm basically trying to make is all those connections, the majority of them, seem to finally stop in about the mid-20s. And that's probably linked to the age factor with this disease. The question basically is, after she was given some immunosuppressive treatment and got the antibodies out of her system, how did the brain recover? And that brings up a really good point, in that in some patients, if you do not treat quickly enough, the brain damage may be irreparable. They won't recover as wonderfully as Susanna did. And there's a 4% mortality rate, which means 4% people die from the disease. But with the steroid therapy and the plasmapheresis, which is basically a filtration system, you take out the person's blood, you get the bad antibodies filtered out, and you put the blood back in their body. Those treatments basically stop the brain attack. They get the attack under control. And what's really going on at a molecular level is that the antibodies in her system, I assume everyone knows antibodies are, it's basically generating collateral damage. Her body thinks it's under attack, but it's actually attacking itself. And it's specifically attacking something called the NMDA receptor, which is located at brain synapses, which are the gaps between neurons that facilitate communication from one neuron to the next. So what happens when this antibody binds the receptor is the receptor gets internalized. And if that happens to a large extent, there's not going to be a lot of those receptors on the surface of the neuron any longer, which is going to decrease the signaling capacity from one neuron to the next. So basically, her brain can't think. It's been short-circuited. And when they did the tests of where exactly, because these NMDA receptors are all over the brain, but the ones that are attacked seem to be localized in the hippocampus and the prefrontal cortex. The hippocampus is critical for learning and memory, which are symptoms that she exhibited. It's also important for spatial orientation, which is one of the problems that she had. And it's also important with the amygdala to govern emotions. And clearly she had a lot of emotional problems as the disease settled in. In the prefrontal cortex, that's an area of even greater concern, because that is where personality is usually seated, and that is where your logic and reason circuits are. So those were all taken out of commission by these antibodies. The good news is, as soon as you get rid of them, the receptors start to repopulate on those neurons, and things pretty much resume as business as usual, as long as those antibodies don't come back. So in addition to the treatments she received, I don't believe she had the tumor, but about 50% of patients do. It's critical to find that tumor and remove it so that it can minimize relapse. Did you guys understand how a tumor is connected to this disease? So these teratomas are really creepy. I think one of them came up in an episode of House. Teratomas are not an ordinary cancer, and they usually happen in the ovaries or the testes, most often in women. And they're unusual in that they're not a single cell type. They can be multiple cell types all into one. So you can have a teratoma that is comprised of brain cells, that is comprised of bone, muscle cells, even hair. So it sounds kind of gross, but the teratomas that have brain cells probably have this receptor expressed on them. And as the body is trying to attack the tumor, it develops antibodies to those receptors, and then those antibodies go to the brain by accident, and that is how the disease probably manifests itself, at least in that percentage of the patients. Based on the research papers I've read, this is highly skewed towards females, about 80%. Now, there's about 20% of men who have exhibited this autoimmune disease, but by far and away, it seems to occur in women. And just as a corollary to that, these teratoma tumors more commonly occur in women, so that probably skews the bias of the epidemiology to women too. If I'm going to talk about immunology, I need a beer. When I was in grad school, I had an immunology class, and there were like 9 interleukins known, and now there's like 120. So immunology has advanced incredibly, and I can't keep up with that literature anymore, and I have no desire to. But I can tell you a little bit about autoimmune diseases in general, and I guess in relative terms, it is a pretty recent discovery in medicine. The big first discovery were germs back in the 1850s or so that were the causative agent of many of our diseases. And then once genes were understood and the solution to DNA was resolved, we started to understand more genetic components to diseases, and there's probably going to be many more of them in the future. But autoimmunity is relatively recent because the immune system is a relatively new discipline. It's really only been appreciated probably since the 80s. And unfortunately, it was the advent of AIDS that inspired us to learn much more about the immune system, because AIDS underscored how important it really is. With regard to autoimmunity, that is basically when your body mistakes a part of you as being foreign, and it mistakes a part of you as something it needs to attack. And we don't precisely know why that happens, but we do know that there's individual variation in the rigor of people's immune systems. There are some people born with poor immune systems. The worst case scenario would be like the boy in the bubble. Okay, you're all familiar with that Seinfeld episode where they were antagonizing the boy in the bubble, or vice versa. And then at the other end, we have hyperimmune individuals who are allergic to everything. You know, it's a bell curve. Most of us are somewhere in between, where we have maybe an allergy to cats or allergy to hay fever or something like that. But for the most part, we're fine. So the immune system is incredibly complicated. We don't know why it responds appropriately to some, what we call antigens, and then gets hyper-responsive to others. We do believe there's a period of programming in development. One of the more recent ones is peanut allergy. You know, we really never heard of this when I was growing up. It just seemed outlandish. It seemed very foreign to us, but it's very prevalent today. And it's a very real phenomenon. And studies have come out, and they seem to contradict each other, but the initial advice was, don't give your kids, don't expose them to peanut allergens. And now doctors are saying the reverse. If they don't get that exposure when they are young, which seems to be a critical window of development where the immune system is educating itself as to what is foreign and what is not, if it miseducates itself or misses that opportunity, then you're kind of screwed for life. So there's a critical window of development, just like for brains, for the immune system, that happens when we're young, and that probably dictates what things we're allergic to. Yeah, I've read mixed literature on that because I was interested in the same exact question. There's no doubt that we're getting better about diagnosing things, so that kind of makes the question a little difficult to answer already. But I do think there is at least a marginal upkick in autoimmune diseases. And there's this interesting idea out there called the hygiene hypothesis. Some of you are familiar with that. I can see by the nods of the heads, whereby maybe we're living now in too sterile of an environment. And that critical window that I spoke about earlier, where our immune system has to be trained more or less to recognize self from non-self. If we are living in too sterile of an environment, the immune system doesn't get that training. And the consequence is a higher degree of autoimmunity as we age, because the immune system needs something to attack. It needs something to do, so it goes after the body. So the hypothesis goes. Right. So they gave her a very aggressive treatment with 3 different categories of immune medication. So for just broadly speaking, all autoimmune diseases, the whole goal is to get rid of the offending antibody, because the antibody is attacking, like in arthritis, it's attacking cartilage. Maybe for colitis, it's attacking the intestine. And in this case, it's attacking a brain receptor. So you want to get rid of that antibody. One of the ways we can do that is to give the individual steroids. And what steroids are going to do is diminish the capacity for the immune system to respond to anything. And that's why people who are on aggressive steroids are very susceptible to catching colds or other infectious agents, because their entire immune system is depressed from those steroids. But it's a very effective way to get offensive antibodies under control. The second treatment, as you already alluded to, was one where you take, it's called IVIG. It's an extremely expensive treatment, and it is comprised of like the serum from 20,000 different people into one IV bag that gets put into you, in the hopes that amongst all those individuals, there's something in their blood that can attack that antibody and get it under control. And then finally, there was plasmapheresis, where you draw her blood out, filter away the antibodies, and then put the blood back in. So that triple threat really helped to get the disease under control. And once it went into remission, she was able to stop those medications. Yeah, that's a good question. It dives into a can of worms that is very unpleasant. People who have the resources are going to be fine. People who don't are not. And it is convenient to put these individuals into institutions or dismiss those effects as stress or some other neurological condition, because as Susanna hinted in the book, she had sympathy for Dr. Bailey, even though he was misguided at the beginning and gave her the wrong diagnosis. She had sympathy for what he was going through in seeing upwards of 35, 40 patients a day, where he was very limited, maybe 5-10 minutes with each patient. That's really not quality time to get to understand the condition. And we've probably all experienced this just by seeing our general practitioner, where we feel like the doctor is really just in a rush and we're on a conveyor belt, and it's just, okay, what can I get you to the pharmacy and get you better? These kind of cases have to be treated with much greater care, much greater diligence and attention, and they have to be individualized. And frankly, I just don't think we're putting the correct resources into programs that will allow us to do that. So that's a decision we as a society have to make. If we want better health care, do we want doctors to have more time with patients? We need to maybe form a grassroots operation to change how the medical system currently is. Because right now it's resource driven. If you are lucky enough to be able to afford the best care, then you'll get it. So did this book give you guys any thought about who you are, or any existential thoughts crossed your mind? Because she was really robbed of herself during the progression of this disease. The disease robbed her, denied her of her personality, her memory, and the essence of who she was. And some people who haven't had their coffee, that can be horrible, and they're monsters. So we really are a multitude of different selves, if you will. There's a concept in psychology called multiplicity that speaks to this, and it's the hypothesis that the self is an illusion. There really is no single you out there. And whatever you conceive in your head is probably completely different than what your friends, families, and strangers think of you. So it just really opens up, I think, some really interesting questions as to what we really are, and how, again, I think fragile is a great word, how fragile our persona really can be. The slightest little parasite, injury, or tweak of the brain, lack of sleep, can dramatically change who you think you are. And it begs the question, well then, if you can change so readily, and if you're so much different now than when you were 5, 10, 15 years ago, who are you really? It's a really interesting question. I think you are who you are today. But to think that you have some kind of static personality that doesn't change, I think is misleading, because you behave differently around different people and in different contexts. And I think that just goes to the remarkable adaptive nature of our brain. As many shortcomings as our brain might have, it's really quick to think on its feet and almost automatically can tailor your responses to different people. That's what I think, for what it's worth. That's right. It might change. One more beer, it could all go out the window. I'm out of beer. I can't talk about that.
Special thanks to our featured speaker, Bill Sullivan. Our team is Carrie Sinovoy, Leah Namias, and Melanie Fox. Books, Booze, and Brains is a partnership between Indiana Humanities, Central Indiana Science Outreach, the Indiana State Museum, and March for Science Indianapolis. Our live stream was brought to you in part by a grant from Indiana Sciences. Music was provided by Sunset Pig. You can listen to Springtime Stretch, the song featured in this video, and other songs at sunsetpig.bandcamp.com. This video was produced by denkbots, which you can find at denkbots on Facebook, Instagram, and Twitter. Kyle Turpin is our recording engineer. My name is Rufus Cochran, and as always, learn, create, inspire.
Okay, I'm sorry. I just feel like I'm blabbing the whole time. All right, I'm the trophy scientist.